Today we're writing proofs that are going to involve segments and angles, and there's some little nitpicky notation type of things that are really important in proofs. So this is a very detail specific, these are very detail specific definitions. So when we're talking about segments being congruent, let's say we have segment AB and we want to say that it's congruent to segment CD. To communicate that something is a segment, we draw that bar on top. No arrows. Arrows mean it's a line, but if we're talking about two segments being congruent, it's the segment with the bar on top is congruent. It's the equal sign with the little squiggle on top, and then another segment with the bar on top. So that's talking about a thing is congruent to another thing. These specific segments are congruent to each other. But if you were to take a ruler and measure the length of a segment, that would be like in inches or feet or yards or something like that. It would be a number. So you wouldn't use a congruent sign with a number. You would use an equal sign. So when we're talking about the length of a segment, if we're ever using an equal sign, maybe we're writing an equation or we're setting it equal to a number, we're not going to use the congruent symbol. We're going to use the equal sign. And when we are setting segments equal to each other, we're talking about their length, and we're not going to put the bar on top. So the way that I remember this, which one's which, is if your equal sign is wearing a hat, then your segment is wearing a hat. So I'm saying like the little squiggle and the line, these are your hats. They're wearing a hat. So if your equal sign is wearing a hat, then your segment is wearing a hat. If your equal sign doesn't have a hat, then your segment doesn't have a hat. So if we are going from our segments being congruent to our segments being equal, or vice versa, if we're going from our segments being equal to our segments being congruent, so if we're putting on the hat or if we're taking off the hat, that is the reason in your proof is the definition of congruent segments. So let's go work a proof with this. Let's do number 2. So this is on your notes. This is number 2. Given that segment CD is congruent to segment EF, CD is equal to 3y minus 9 and EF is 15. So let's go ahead and put that in our proof as our first statement. And hopefully you already notice that the first statement has a congruent symbol and the second two parts of the given have equal signs. So CD is equal to 3y minus 9. That has an equal sign. So I notice that CD is congruent to EF. That does not have an equal sign. So I want to switch that statement from having a congruent symbol to an equal sign, because if I have all equal signs, then everything that I can substitute and transitive and do all that stuff. So the first thing I'm going to do is I'm going to take segment CD is congruent to segment EF, and I'm going to rewrite it. Those all have hats on. My segments have hats on, and my equal sign has a hat on. So I'm going to take the hats off. I'm going to go ahead and say CD is equal to EF. I've switched it from having a congruent symbol to an equal sign. They all had hats on, and so I took the hats off. And that reason is the definition, and you can shorten definition to DEF, of, and you can even write the congruent symbol if you want, but congruent segments. Whoa, that's an E. Congruent segments. I don't know why it won't let me write an E right there, but congruent is what that says. Okay, now I have CD, 3y minus 9, EF. And 15. I have 4 terms. The orange one, the yellow one, the purple one, and the pink one. CD, EF, 3y minus 9, and 15. Those are 4 terms. Remember, 3 T transitive, but 4 terms you're going to use substitution. So my next statement is I'm going to swap the 3y minus 9 in for CD. And I'm going to swap the 15 in for EF. So when you're swapping stuff, plugging stuff in, that is substitution. And notice I used 4 terms, not 3. So when you have 4 terms, it's the substitution property. And so now you can take it away. I'm just going to solve this for y. So I'm going to add the 9 to both sides. So that would give me 3y equals 24, addition property. And then I'm going to divide by 3 on both sides to get y equals 8, division property.